Okay, what's up guys? Welcome back. And I'll be doing chapter 9, interfaces and polymorphism. Using interface is pretty easy. There's not much to go over really. I feel like this isn't something really needed. So we'll go on to that's when I talked about forgetting this is fine. Constants in an interface. So essentially for the interface you can have these common compiled what is it? These constants in the interface are basically essentially instance fields, but instead of them being like private, like int or private whatever, it's going to be a static final. So it's essentially the same thing except it's like a set value, it's a final. And these are called constants in an interface. So whenever you make a variable in the interface, it has to be a final or static final. So then it'll be like capital letters. And if you're making them in the interface, you don't have to say public static final because that's its default. So you can just say int north and it'll know that it's a public static final int. And then I want to talk about converting between a class and an interface. So the thing is, like, I don't know, like the way Jay said it made a lot of sense. So this is what Jay said, and it's gonna kind of say what Jay said. So essentially, when we look at it like, see like measurable x equals new account. So we know measurable is the interface and we know account is the bank account, right? So account implements measurable. So that means account knows that measurable exists because it's implementing it. And so then you can implement, this is allowed, this is valid because account knows x, right? And same thing here. Dime is the coin class. It's an object from the coin class, and it implements measurable. So since coin implements measurable, coin knows that measurable exists. That's why it's allowed. So if we go into the unit review and we do that valid or not valid, here's the thing, right? So the interface, A is an interface, does not know that the class exists, right? Because it doesn't know that it's the interface does not know the class is using it. That's why it's invalid, because the interface does not know the class is a thing. But in this scenario, it is valid because the class knows that the interface is a thing because the class depends on the interface. So basically, essentially, if the thing on the right knows about the thing on the left, then it's valid. But if the thing on the right does not know about the thing on the left, then it's invalid. So we can go here and see A does not know C, but when A becomes part of this class C, then the class knows that the class exists, so then it is valid. And then this is the same thing as this, except it's redundant because there's no point of setting C, which is already part of the class, to itself. So it's saying you're casting an int to an int, for example. You're casting the same class to itself. It doesn't do anything. It's just redundant, but this is still technically valid. This is invalid because of the fact that B does not know A exists, right? This interface B does not have any relationship with the interface A. It does not know it in any way. That's why it's invalid. And this one is correct because C knows that B exists. So C is the class that depends on this interface. So C knows that B exists. And this means all the data in C is getting stored in B. So B is essentially C, but it's not the class, but it's the interface, but it has all the data of C. And now when you're converting B into type A, it's valid because B has the data of C. So when it gets converted to A, all the data of C is still there with it. So then it just becomes C, but in the same type as the interface. So this interface becomes A again. So A equals A. And since they're both in the same interface, they know each other. And since C, like C implements A, then it has all the right data in order for the uh, casting to work properly. If B was not equal to C, then B can't get cast into A correctly because B does not have the correct data in order to be cast. The only reason it's working is because B has the data from C, and that data from C can be casted into the interface A because C is dependent on the interface A. And now I want to talk about late binding and early binding. So early binding is when a method is overloaded. So essentially, a method overload could be like a constructor almost. Like you don't know which one it is, and like it depends. So like if I bring up, what is it? If I bring up here, let me get something. Right? If I bring up this and we have car, right? Car can have a public car, but at the same time, it can have a default, right? Let me so we could have this, and we're just gonna say the make of the car is A. Okay, and we'll say it's 1, 2, 3. So now if we go and compile this and then go into the tester, we can make a uh, car equals new car, right? So this is one way of making a car, and car. This is another way of making the car, right? There's two different ways to make a car. There's two different methods to make a car, right? So this is early binding because you know exactly what data will come out of what car. If I change this to B, for example, oh wait, this name, it can't be the same name. I'll make it R. Yep. So essentially, for early binding, we know exactly the moment it compiles what the data is going to be. We know that in this, the data is going to be BAA123 because we know that straight out of the compile. And we know for car bar, we know the data is going to be exactly AAA123 because that's what we have compiled. It's overloaded, but there's two different methods, so we know straight out of the gate what the data is going to be. But for late binding, it's different because when you have polymorphism or when you have an interface, like let me make an interface. Here we go. Here's our interface sus, right? It has int yip. Okay, that's, don't question the names. That is the abstract method that it has in the interface. And the bus has public int yip, right? And here's the thing. Okay, let me make another variable that another class that implements. We'll have it plain, right? Plain will have the exact same thing as the exact same thing as bus, right? It's the exact same thing, but let's change the number. Let's just change the number here. So we have two classes. We have bus and we have plain that both implement sus. And if we go to our tester and we create sus bus equals new bus, Oh, is it lowercase? It's plus. And then we have sus plain equals new plain. And you have a, can you do math dot random 0 comma 0 comma 1 or 0 comma 2? I don't know what this is gonna let's do this. X equals is this how this works? I'm not sure. How do I do math at random? This how I do math at random? What is this, bro? Is this not support? That's not true. Or I don't think we need math at random. We'll just say if, how would I do this? Okay, we'll just use the array list that's already here, I guess. We'll just make an array. Let's use, we'll take inspiration. How do I make an array? Okay. Okay. Kind of forgot. We'll just do random array equals. It has to be like an int, no? Or like object. Is this allowed? Whoa, that's cool. And if we say object dot get 0, no, is it 0 dot yip, right? And we do system dot print. Let's hope this works. We're not sure. Well, technically, right now we know what it should be random. Wait, dot yip. Do I not have dot yip? Or should I do like stuff? Oh, we're actually cooking, guys. Like, let's say you didn't know what plane was, you didn't know what bus was, right? You didn't know what it would return. Like, can I do a random number generator? Like, with this one? Return. What? Okay, right? So for bus, you're not sure what number it's gonna make. And for plane, well, you know it's gonna be 15. But if these were randomized, you wouldn't know what random would create, right? You would only know it after you run it. So let's run it and hope everything works as intended. 15. That's fair because plane was 0. So if we did 1 and then oh, and ran it again, compile, run 0. Well, that's a random number. It doesn't matter. So the thing is, right, you only knew the number after you ran it because it's a late binding, because you don't know what yip is going to be. Like if it was a random between 1 and 0, if it was a random number, you're not going to be sure until you actually run the code what the output is going to be. But for this case, you know immediately as you compiled it, what the data of car is going to be, what the data of bar is going to be, right? As soon as you made it. So whatever, what, like get make, as soon as you saw, as soon as you had bar.get make, as soon as you compile it, you know the answer. But in this case, you don't know random1.yip because there's two classes that have different returns for yip. Bus is a random number and plain is 15. And if you didn't if you didn't know what this was, you wouldn't know the answer until you ran it. So that's the difference between early binding and late binding. Okay. Um, what else? Something else I want to talk about, I guess I'd say, is in the readings I saw instance of. I mean, he said it's not going to be on the AP test, but like you never know if it's going to be on our test. So like I'm gonna just go over it. It's not much really. It's just basically saying that if the instance of keyboard can be tested to see if an object is of a specific specified type. What the heck? I lost my words. If the object is part of a specified test or type. So if the object reference is an instance of a type, so this is basically a true, it's either a true or false. If it's true, then the if statement runs. If it's false, it doesn't. And I want to show, like I want to run it first, but also like you see like a string s, right? So this should be true because s is a string and string is of the type Java, that length string. And no matter what, apparently, if it's null, then it will always return false. I don't know why it just does, but now I want to test it out. Boom, get rid of this. I'll move that up here. Okay, let's do this. We'll say if bus instance of sus, then we system.out.print. Huzzah! I huzzah! Right? So if bus is part of the instance is part of sus, then it prints it. So if it's true, we'll do that. The same for plain. Okay. And instead of, we'll make a new one. Right? If bus or if bus or bus bus us equals new bus and plain planes equals new plane. Let's see if that's still technically part of the sus. It sounds so stupid, but yes. So let's see. Technically, sus, even though it's not part of the instance, the interface sus, and now it's just from the regular class, we'll see if it is still an instance of sus. And finally, I just want to do car, cause like car and bar. Because these two have nothing to do with sus too. So let's see if it works. I'll change like the amount of explanation marks so you can see the difference. They're all different. Now we compile. Now we go here, go to the tester. Let's see how many huzzahs. What is it? Huzzah, huzzah. Okay, that doesn't matter. Huzzah, 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 huzzah. So the first four, right? 1, 2, 3, 4, were in fact working. So that means, well, bus is an instance of sus because it is from the interface sus. Plane is an instance of sus because it is sus. But what's interesting is us is also an instance of sus, even though it does not directly use sus, it directly uses bus. So if you see that, these two are directly from the interface sus, but these two are not directly from the interface sus. They are, in fact, from their own classes, but it still worked, which might be on the test, like, is bus us, new bus, still an instance of sus? And right now, from what I could tell, it is, because us is an instance of sus. So maybe that means since the class bus is implementing sus, no matter the variable, it will always be an instance of sus, which is cool, which is important, might be important for this test. Yep. And these obviously didn't work because car and bar, they weren't implemented by sus. They had nothing to do with sus, so obviously it didn't work. But I'm gonna try something. So if I did this, right? If I just added a simple, if I just did this, would have the huzzah. Let's try it out. And look at here, we have huzzah, huzzah. Yep, that's 6. That means the last one. So that did work. So it is if it's not an instance of sus. So that's cool. We could still use the whatever the knots and stuff for instance of. I don't know if it's gonna be useful on the AP test, but it might be useful on our test tomorrow. So and that's basically all I wanted to talk about. I don't know, this unit wasn't much to say really, so hopefully I maybe explained the late binding and early binding better. Maybe this instance of may come in clutch during the test, who knows? But for now, hopefully you guys do good on your test. That's all I gotta say. Bye bye. How do I turn this off? Where am I? Okay, bye bye.